This is section 3 of chapter 8, so page 721. And this is the geometric one. So this means we're multiplying each time by something. So that's what that R means. It's the common ratio. So if you've watched the videos on the other things, you hopefully understand a little bit more of what I'm talking about. So if A1 is 7 and we're multiplying by 2, the next one is just 2 times 7, which is 14. I'm multiplying that by 2 again, so that's 28. Multiply this by 2, so that is now 56. Double that, so that's 112, and double that is 224. So that's it. That's number 19. I might make mistakes here and there. If I do, I'm not doing it on purpose today. Today's just struggle day. So anyways, if I make a mistake, let me know. A2 is A1 times negative 2/3. Okay, so what that means is we're going to multiply by 24 and divide it by 3, or go 24 divided by 3 and multiply that by 2. That's what I do, just because it makes it a smaller number. So 24 divided by 3 is 8, times 2 is negative 16. So now I'm going to take that number and multiply it by negative 2/3. 16 is not divisible by 3, so I just multiply the top. 16 times 2 is 32 over 3. So A4 is 32/3 times a negative 2/3. So 3 times 3 on the bottom makes 9. 32 doubled makes negative 64 because it's a negative 2/3. So now I take negative 64/9 and multiply that by negative 2/3. So 9 times 3 is 27. Double 64 makes 128, and a negative times a negative makes a positive. So 128 over 27, multiply that by negative 2/3. 27 times 3 is 81. Double 128 makes 256. Yeah. And so that's what 21 is asking you to do, is find the first 5 terms. Probably didn't have to find A6, but oh well, that's how we would do it. Okay, question number 23. It says find an equals 1/2 an minus 1 for n is greater than or equal to 2. Let's see. So we are supposed to write the first 5 terms. Okay. So we know what A1 is. What's A2? Well, that's 1/2 of A2 minus 1. So that just means 1/2 of A1. Well, half of A1 is 18, because that's 36. A3 is 1/2 of A3 minus 1. Well, 3 minus 1 makes A2, so it's just half of A2. A2 is 18, so that's just 9. A4 is 1/2 of A4 minus 1. Whoops, minus 1 down here. So 4 minus 1 is A3, so that's really just 1/2 of A3. So half of 9 is 9/2. A5 is half of A5 minus 1. Well, 5 minus 1 makes A4, so that's 1/2 of A4. A4 is 9/2, so that makes 9/4, because you multiply the 2 and the 2 together, and that gives you 4. A6 is 1/2 of A6 minus 1, which means it's just half of A5. A5 is 9/4, so 4 times 2 is 8, which makes 9/8. So that's 23. 25 is asking you to write a formula for the nth term of the geometric sequence. Okay, so we want to write the general form. So if you remember, it's an equals a1 times r to the n minus 1. So an equals my first term, which is 5. 5 to 10. So an easy way to find these is just divide the second term by the first term, the third term by the second term, the fourth term by the third term, and you get the same thing on all of them. That's the common ratio. We're multiplying by 2 each time. 2 to the n minus 1. And that's my formula. That's it. Ta-da. Okay, number 20. Come on, computer. 27. Again, it's a1 times r to the n minus 1. Well, a1 is negative 2, so that's the easy one. Now to figure out what r is. What do I multiply negative 2 by to get to negative 1? What do I multiply 1 by to get to 1/2? What do I multiply 1/2 by to get to 1/4? Well, I'm just going to take the second term and put it over the first term. Oh, it's 1/2. Or I'm going to take the third term and put it over the second term. Oh, it's still 1/2. So the r is 1/2. N minus 1. That's our formula. You don't have to find anything else other than the formula. 35, though, it does want you to find the sixth term. So let's again find our formula. So the second term divided by the first term, each of those are divisible by 4. That makes negative 2/3. So that's my common ratio. So A1 is 12. My common ratio is negative 2/3. N minus 1 is my general formula. So if I want to find the sixth term, all that I need to do now is plug in 6 for this n. So 12 times negative 2/3, 6 minus 1, which is 5, so 12 times negative 2/3 to the 5th. All right, calculator, time for you to do your magic. 12 times negative 2 divided by 3 to the 5th. Had a quick thought. Positive, negative, so it is a negative r. Okay. Enter. Well, I like a fraction better today. Negative 128 over 81. Negative 128 over 81. And that's our answer. That's the sixth term for number 35. 37, find the 12th term given this. This one's a little bit more tricky, but we can figure it out. A1 equals 2. A2 equals 2 times r. A3 equals 2 times r times r. A4 equals 2 times r times r times r. Well, A4 is 16. 2 times r cubed, because there's 3 of them. So now I can figure out what r is. I can just divide it by 2. So 8 equals r cubed. Take the cube root of each side, and I get that r equals 2. Hey, now we can plug some stuff into a little formula, let our calculator help us, and life's grand. So A12 equals A1, which is 2. R is also 2. 12 is our n, so 12 minus 1 is 11. So now I just come to my calculator. 2 times 2 to the 11th. Work your magic, calculator. There it is, 4,096. Whoops, 4,096. So that's our answer for number 37. 39. You're supposed to find the seventh term. I don't know what the first term is, but I know what the r value is. It's 1/2. So half of what number made negative 6? So here's what it would look like if I did it this way. Half, whoops, no. Half of what number equals negative 6? Well, half of 12 makes negative 6, but it has to be a negative 12. Or you could have said this. And dividing by a fraction is the same as multiplying by its reciprocal, which would give you negative 12. So I now know what A1 equals. I know what R is. So I know AN equals A1 times R to the n minus 1. So if I have A6, well, that's A1, which is negative 12, times R, which is 1/2. And N is 6. So 6 minus 1 is 5. So now I just come back to my calculator. Negative 12 times 1 divided by 2, all to the 5th power. Decimal, we don't like a decimal. We're changing it to a fraction, negative 3/8. Oh, I read the question wrong, though. It says find A7. I put down A6. So if I multiply that by 1/2 again, I get negative 3/16. That's A7. Okay, 49. There is a formula for this. I will show it to you, but most of you won't use it. It's A1 times 1 minus r to the n all over 1 minus r. So A1, I plug it in. So I plug 1 in there. 1 minus 1 is 0. Anything to the 0 power is 1. So 3 times 1 is 3. So the first term is 3. So I'd replace that with a 3. So I'd have 3 times 1 minus my r. This is always the r that's inside of here. Remember in our formula we said it's A1 times r to the n minus 1. Well, there's my r. Okay, A1 r to the n minus 1. When it's set up like this, that's how the pieces fit together. So 2, this is to the n. So be careful that you don't read and be like, oh, that's n. No, it's to the n, which is this number up here, which is 10. All divided by 1 minus 2. So now I come to my calculator. And I'm going to put the top in parentheses. 3 times parentheses 1 minus 2 to the 10th. Close my parentheses. Close the top of my fraction divided by the bottom fraction 1 minus 2. And hit enter. So 3069. So the sum of all the numbers, that's what this means. The sum of the first 10 terms is 3069. So if I were to get all the first 3 terms, so the first term would be 3, the second term would be 6, the third term, 3 minus 1 is 2, 2 squared is 4, times 3 is 12, and I'm starting to pick up a pattern. I'm just multiplying by 2, 24, 48, 96, 192, I hope, 384. These are starting to get iffy in my head. 384, 768, A10, 16, 3, 14. Then you would add these all together, okay? Now, here's the shortcut way. We go to our calculator, we hit math, 0. Ah, there it all is. Now I just plug stuff in. N equals 1 to 10, so I'm going to use x, 1, 10. Now I'm going to move it over into here. And it has 3 parentheses, 2, n minus 1. So 3 parentheses, 2 power. I'm not using n, I'm using x minus 1. Then I move it over here, get out of that parenthesis, and I hit enter. And it gives me the same answer. Okay? So a little bit easier. So again, on this one, if I wanted to find the first term, I plug 1 in. 1 minus 1 is 0. 3 to the 0 power is 1, times 4 is 4, so that's my first term. So A1 is 4. R is 3, so I would set up my formula. 4 times 1 minus 3 to the n, all over 1 minus 3. So then I would come to my calculator, parentheses for all the top stuff. 4 times 1 minus 3 to the 8. So 8's the top number. 3 to the 8th. Come back down, close the top parentheses off, divided by 1 minus 3. 13,120. Or I can hit math, 0, x, 1, 8, and then we had 4, 3 to the n minus 1. 4 times 3 to the n minus 1. Whoops. X minus 1. There we go. And I get the same answer. Okay, so that's both methods on how to do that problem. Okay, 51, same thing. I'm just going to type it right into my calculator. Math, 0, x, 1, 7, 6 to the 6, and then 2/3 k minus 1. 6 times 2 divided by 3, up arrow, x minus 1. Come out, hit enter. So 16.95. Or 4,118 or 243. Okay, 53. This one's a little bit tougher. It doesn't have it set up for us all nice and pretty. This is my first term. If I were to get to here, 15, I can go 5 divided by 15. That's 1/3. I could go 5/3 divided by 5 over 1. Dividing by a fraction is the same as multiplying by its reciprocal. The 5's cancel. I get 1/3. So that means r equals 1/3. I have 1, 2, 3, 4, 5, 6 terms. Okay, so if I were to create a formula, it would look like this. K equals 1 to 1, 2, 3, 4, 5, 6. The first term is 15, and then the r, n minus 1. Okay, or I could just type this in the calculator, hit enter, math, enter, enter, and it'll change it back to a fraction. So math, 0, x, 1, 6, 15, 1 divided by 3 to the 6th term. Math, enter, enter. 10 over 81. That doesn't make sense. Math, 0, x, 1, 6. Oh, I know what I did wrong. 15 times 1 divided by 3, up arrow, x minus 1. There we go. Enter. Math, enter, enter. 1,820 over 81. That makes more sense. Because 15 wholes, that's 15 plus 5 is 20. So that's how I looked at that first one. I was like, something's not right, because when I looked at this first one, it was 10 over 81. I'm like, that's not even 20. I know my answer is over 20. So that's why I was like, something's wrong. So there's the mistake. Okay, so make sure you type it in just the way that it looks so that you don't have the wrong answer show up like I did. So on 55, we are multiplying by 3 each time. So an equals a1 times r to the n minus 1, right? Well, I don't know what r is. Whoa, get back here. Well, I do know what r is. 2 to 6 is 3. 6 times 3 makes 18, so r is 3. My first term is 2, n minus 1, and I get 13,122. So let's solve for this n right now. So I'm going to divide everything by 2. So 13,122 divided by dos. 6,561. 6,561 equals 3 to the n minus 1. Now you've got to dust those cobwebs off inside your head and be like, we have a number that has a power that's a variable. How do we do this? And hopefully somewhere in your brain it's like, da, 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 come on, come on. And it says logarithms. Oh yeah. I go log of 36561 equals n minus 1. So now I come back to my calculator. I hit math. Log base 3. See, there's the 3. And then 6561. Whoa, 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 whoa. What are you doing, computer? Sad thing about a computer, it only does what you tell it to do. 6561. And then you hit enter. Oh, and it says it's 8. So this is 8 equals n minus 1 plus 1 plus 1. N equals 9. So there's 9 terms. Okay? The reason that's important is now I can do this. X equals 1 to 9. Then my formula, my first term is 2 times r, which is 3 to the n minus 1. Now I can just type that right into my calculator. So I can hit math, 0, x, 1, 9, 2 times 3 to the n minus 1. 2 times 3 x menos 1. Restado por 1, I think. And then we get the answer out, 19,682. So that's how we do that one. Now, 65, I want you to think about this a little bit differently now. This says infinite. We are going to keep adding numbers forever and ever 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 and ever. So if I had 1 and then I multiplied it by 2 and then I multiplied that by 2 and I kept adding these ones together, it would just keep getting bigger and bigger and bigger and bigger. Okay, it would never get smaller. But now I want you to think about this. Suppose my first number is 1 and I multiply it by 1/10. And I multiply that by 1/10. And I multiply that by 1/10. And I multiply that by 1/10. My number is now this. And it's going to keep going like this forever. This number out here gets so small that it's like I'm not even adding anything in there. I mean, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That's 21 decimal places out there. That's I mean, you can't even see that small. With a microscope, you're having a hard time seeing to the 9th, down here to the 9th decimal place. Okay, so when we're saying 21 decimal places, it's like it's not even changing its size. Now think about it out here, like out there to 100th of those. It's so small that nobody even cares what it's doing. Okay, so as long as this number right here is less than 1, okay, not just less than 1, it has to be the absolute value of that number is less than 1. Okay, it doesn't do any good to be like, yeah, 2 is less than 1, woohoo. No, because then you have like -2 and then like -4 and -8 and -16, and those just keep getting bigger, bigger. You're just in the hole further. Okay, so the only way this works is if that is the absolute value of that is less than 1. If that's the case, here's the simple formula: a1 over 1 minus r. So the first term, I plug 1 in here. 1 minus 1 is 0. Anything to the 0 power is 1. And then just 1 minus 2/3. 1 minus 2/3 is 1/3, so it's really 1 divided by 1/3. Dividing by a fraction is the same as multiplying by its reciprocal, so I get 3. I could do it on my calculator. What we found on the calculator is that you have to type in 99 on the top. And even then, that's really big. But we decided that that's probably that's as close as you need to go to infinity on this. So 2 divided by 3 to the x minus 1. And it takes a while to think on this, just so you know. That 99 really, you have to realize that's a lot of times for this. I think we decided we could even do like a 19 and you get the same answer. Okay, so there's the 3. Speed processes up a little bit. Let's just try what happens if you would have put a 29 in there instead. So 29 gives you 2.99. So not quite as good as 99. So, or you can use this formula. So 67 to the 3/4, or 66 to the 3/4. So that's smaller than 1. So I can come to my calculator, math, 0, x, 1, 99. Do we have a number in front of that? No, just 3/4. 3 divided by 4, up arrow, x minus 1. Enter. Like I said, be patient. So it's 4. So we could have really just typed this in like this. A1, we plug 1 in here. 1 minus 1 is 0. Anything to the 0 power is 1. So it's A1 over 1 minus r. 1 minus 3/4, which is 1/4. Dividing by a fraction is the same as multiplying by its reciprocal. So I get 4. Okay. I look at 67, 3/2, and in my head I'm like, oh yeah, this is great. It's an infinite one. But then all of a sudden I'm like, 3/2, that's bigger than 1. This thing's never going to stop. So it's going to keep getting bigger and bigger and bigger. It's not possible to find this. You can't do it. Okay, 68, 4 divided by 3. Yeah, same problem. That's bigger than 1. Not going to happen on that one either. 69. So we're back to the same thing. So I just come to my calculator. Math, 0, x, 1, 12, 4 times 2 to the x, 4 times 2 to the x. Remember, I changed all my i's to x's. And I hit enter. 32,760. Okay. So anyways, that's how you do those problems using your calculator and also doing it by hand. So calculator does help, but you can do it by hand as well, and it works out the same. So anyways, that's those problems.